Welcome to Chapter 11, Calculating Ka or Kb from pH. So in this situation, we are given the pH of a substance, C4H9N. The pH is 10.82, and the molarity of the solution is 1.0 times 10 to the negative third, and we're going to solve for Kb. If they're asking us to solve for Kb, then that probably means we're thinking of this as a base. We know it's not a strong acid or a strong base. Why do we know that? Well, we have a few reasons. One of the reasons would be we've been asked to solve for Kb, and we know that strong acids and strong bases don't have Kb. Why don't strong acids or strong bases have Kb? Because they don't go to equilibrium. But this is not part of our memorized list, so we know it must be weak. We are solving for Kb, so we're going to treat it as a base. You could also look at its pH, 10.82. That's really high, greater than 7, so we know it is basic. So there are all your clues on to why you should think of this as a weak base. So our first step is always identify the major species. And in this case, we don't have to pick between a bunch of different things. There's only one molecule we're dealing with. There it is. And we have just discussed what it is, so I'll write it down. It's a weak base. Okay, next, what do? Write out the equation. So let's try building this out. We'll start with our weak base. I'm going to leave some space here because we might add some things to it. It is weak, so what kind of an arrow do we use? Double-sided arrow. And we know it's a base. So what do bases do? Do they accept protons or do they release protons? Bases accept protons. I'm going to write it like this. If you wanted to put that H in with the other H's, you could, but when you write it out like this, you can tell that that H is bonding onto the nitrogen, and if you were to draw the Lewis structure of the original molecule, you would see that that is where the hydrogen would go. Okay, now here's a question. We have just gained a hydrogen out of nowhere. That doesn't make sense, and science is supposed to make sense. So, where could that hydrogen have come from? If you said water, kudos to you. That's right. It would have come from water. So we need to include that. That hydrogen can't just come out of nowhere. Now, since I took away that hydrogen from that water, what is left behind that I have to include? Hydroxide. Woo! Party. All right, so there's our reaction. Oh, I wrote right out the equation. I'm going to cross that off. Write out the reaction. If you were writing in pen, I'm sorry. That's what you get for writing in pen. Okay, now, what do we do with this equation? We write out our equilibrium expression. Now, if you're taking a test with me, you know that I like to give partial credit for getting partway through problems. So, if you are able to identify the species, write out the reaction and the equilibrium expression, then you've gotten something on that problem, which is awesome. Okay, so equilibrium expression. Well, they're asking us to solve for Kb, so I'm going to write Kb, which means I need my products over my reactants, so that'll be C4H9NH plus and OH minus. Now, what from my reactants am I going to include? I'm going to include everything except for the water. because water is a liquid, we're not going to include it. And we don't know what Kb is. Usually we'd write that on here to keep track of it, but we don't know. That's the goal of this problem. So in order to calculate what Kb is, we need to figure out what is our concentration of hydroxide ions, what is our concentration of C4H9NH plus ions, and C4H9N. It has a name. I just looked it up. I forgot it. Sorry. It starts with like pyro or something like that, which is kind of cool. If you just heard a meow in the distance, you are not going crazy. That is my cat. All right, so if we want to figure out concentrations, what do we usually set up? An ice chart. Set up ice chart. So, okay, C4H9N. I like to write water at the top so that I know it exists, but I have to remember to cross it off. I don't want to actually write any numbers down in its column because it's a liquid, and we don't include liquids in our equilibrium calculations. If you prefer to leave it out, that's totally fine. You don't even have to write it down up here. Okay, so what do I know? I know the molarity of my solution. There it is, 1.0 times 10 to the negative third. They told me that it started off with that concentration. And I know that if I started with this, it has not dissociated yet, so I don't have anything else. I'm not given anything else at all, so I guess I'll start plugging in x's. And since I don't have any coefficients, these are all 1 to 1. My balanced equation is balanced with just 1s as coefficients. Okay, 1.0 times 10 to the negative third oops, I forgot, minus x. Okay, believe it or not, we're almost done. So what we're going to do now is see if we can figure out x. Well, what other information did they give us? They told us that the pH is equal to 10.82. What can we use pH to solve for? We can use pH to figure out, well, the concentration of hydrogen ions, but look at your Kb. Do we need the concentration of hydrogen ions? No, but we need something that's related. We need the pOH, and we know that pH plus pOH is equal to 14. So we can figure out then that our pOH is equal to 14 minus 10.82, which gives us 3.18. Cool. Can I use that pOH to figure out my concentration of hydroxide ions? If you said no, you're wrong. Let's do that. So we know that pH is equal to the negative log of the concentration of hydroxide ions. If I want to get rid of my logs, I have to figure out what its base is. If it doesn't indicate the base, then that means it is base 10. So I want to be able to do 10 to the 10 to the on both sides, 10 to the pH, 10 to the negative log of the concentration of OH. And I want that 10 to cancel out that log. However, I'm erasing these. I don't want that negative symbol in the way. It just messes things up a little bit. So I'm going to switch it to that side. So I'm going to say 10 to the negative pH is the same as 10 to the log base 10 of the concentration of hydroxide ions. The whole point of doing this was so that 10 could cancel out our logs. So we end up with 10 to the negative pH, which is, oops, oh no, Did you notice me doing something wrong? I hope you did. pOH. The negative pOH is equal to the log of the concentration of hydroxide ions. It should be OH over here and OH over there. They need to match. My apologies. So what is our pOH? 3.18. So negative 3.18 equals the concentration of our hydroxide ions. That's pretty cool. So we know the concentration of our hydroxide ions. I need to start not using as much space. Concentration of our hydroxide ions is equal to 6.6 times 10 to the negative fourth. Don't leave off your units. Don't get too comfortable. Okay, well, since I know what the concentration of hydroxide ions is at equilibrium, because this pH is at equilibrium, doop, 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 doop. That's supposed to be an arrow. I now know what the x value is in my ice chart. I can go, hey, x is equal to 6.6 times 10 to the negative 4. That's exciting. So that means I can figure out the concentration of all my other ions, which I need to plug into my Kb. So, okay, my ion C4, oops, H9NH plus is also equal to X. And my original molecule, which is C4H9, just N, is equal to 1.0 times 10 to the negative third minus X, which will give us, you know what, I'm just going to do this. Hold on. Minus 6.6 times 10 to the negative fourth. That's in molarity. I'll just plug in that whole mess in my Kb equation. So, final step. Plug into equilibrium expression, and then we're done. So I'm going back to what I wrote in step 3, that Kb is equal to C4H9NH plus 6.6 times 10 to the negative 4. No exponents because no coefficients. Hydroxide is 6.6. Oh, they're the same. That's nice. And then I know on the bottom I need my original molecule, so I'll put this whole mess down here. 10 to the negative third minus 6.6 times 10 to the negative 4. Okay, crunch those numbers. Let's see, how many sig figs do we want? We want 2 sig figs, so that gives us 0.0013, and that's our answer. So when you get a problem like this and you're stuck, if you get stuck, go ahead and do exactly what you would normally do for any problem in this unit. Identify the major species, write out the reaction, write out, if it's weak, write out the equilibrium expression and set up an ice chart. And from there, see if there's anything that you can figure out. Here we had pH. We could use that to figure out pOH, which we could use to figure out the concentration of OH and go on from there. All right. Hope that helped.